Okay, turn to page 4 in your packet. We are going to talk about how to balance chemical equations. Go ahead and write down these 5 steps, and then we'll just go through some example problems. So feel free to pause the video so you have enough time to do that. Please remember when we balanced equations that we cannot change subscripts. Subscripts are part of the formula and it is written correctly, and so we never ever change them. The only thing we can do is add or change coefficients. That's it. And remember, coefficients represent how many molecules of a substance we have, and it goes to the left of the chemical formula. Okay, also another thing on here, sometimes I just go left to right when I balance, and I always keep hydrogen and oxygen last. Okay, let's do our first little thing here. Go ahead and watch this little video on how to balance chemical equations, and then once you're done, come back and we will do some examples together. Okay, here we go. So let's go ahead and do this lovely chemical equation. I'm going to first do a table, and then I'm going to just show you how we can balance it another way, and you do whatever works best for you. Okay, how come I can't get my little pen to show up? There we go. All right, so the first thing we're going to do is I'm going to make a little table. We're going to have HF and HF and nitrogen and nitrogen. Okay. So the first thing I'm going to look at is right here, HF. How many atoms do we have? Right now we have 1. On this side we have 3. Okay, so the only thing we can do is add coefficients. So I'm going to go ahead and I'm going to put 3 in front of HF on this side. Okay, now that changes to 3 there. So that looks good. And then I'm going to go ahead and balance this next one. Right here we have N2, so we've got 2 atoms of nitrogen on the reactant side. On the product side we have 4. So we need to get this reactant side to equal 4. So remember, we always multiply. So 2 times what makes 2? And the answer there is 2. So 2 times 2 makes 4. Okay, so now we have the right amount. 3HF, 3HF, 4 nitrogens, because we multiply the coefficient by the subscript, and then we have 4 there. So now this is balanced. Another way to look at this, and again, it's all up to what you are more comfortable doing, is not making a table. So for example, right here we have 1 HF on the reactant side, 3 here. So what we're going to do is just add a 3 here. Now we go to the nitrogen and we have 2 on the reactant side, 4 on the product side. So 2 times what makes 4? We'll put a 2 right there. And then we just double check. 3HF, 3HF, 2 times 2 is 4. And then nitrogen has 4, and then we're balanced. So again, do what works best for you. Make a table, do it left to right like I just did. Do whatever works for you. Okay, let's do another problem. So here it is balanced. Okay, this next one, let's go ahead and make a table again. We've got PA and iodine. Okay, on the reactant side, we have 1 PA. Oh, let's go ahead and draw a little line there. On the product side, we have 1 PA. Okay, so that looks great. For the iodine, on the reactant side, we have 5. And on the product side, we have 2. Okay, these are not balanced. So when it comes to something like this, we're going to take the least common multiple of 5 and 2. So what is the least common multiple of 5 and 2? 10. So over here, 5 times what makes 10? The answer is 2, so we're going to put a 2 in front of there because now 2 times 5 makes 10. So now we've changed that to be 10. Over here, 2 times what makes 10? The answer is 5, so then that changes to 10. Okay, now remember, when we balance one element, sometimes it unbalances another one. So let's go ahead and look now at the PA. So the PA now, we have now a 2. So remember the coefficient goes to everything behind it through multiplication. So we have 2 PA now here. So we have to change that. And then on this side we still have 1. So how do we get this side to be 2? Well, we put a 2 right there in the front. Okay, now things have lined up. Let's just double check to make sure. 2 PA, 2 PA, 2 times 5 is 10 iodines, 5 times 2 is 10 iodines. So now we are balanced. Okay, let's do another problem. Okay, this one looks a little bit more scary because we've got more elements, but it's not scary. We're going to do the same thing. It just might take us a little bit longer. So let's go ahead and make a chart. This time I'm going to have an La, a nitrogen, an oxygen, and an Na. And then on this side, again, La, nitrogen, oxygen, and a sodium. I'm going to separate those out. Here we go. Okay, so let's go ahead and start. So first of all, La, we have 1 on the reactant side, 1 on the product side. Okay. Then our N. Okay. Now remember, when we have parentheses, this subscript comes in and distributes just like we do in math. So we've got 3 Na on the left side. And on the right side, we only have 1. Okay. We're only looking at this right here. Okay, so make sure that you are comfortable with that. That 3 right here goes on the oxygen. It's not part of the N. So sometimes you have to isolate your element to look at it. Okay, next one. Let's skip oxygen. Okay. And let's go to our sodium right here. So Na, we have 1 on this side. And we've got 1 on the product side. Okay. Then I forgot to add this. I didn't see it, but we have hydrogen as well. So I'm going to make another little line for hydrogen right here. Okay, and now that I've balanced everything except for oxygen and hydrogen, I want to now do hydrogen, then I'll do oxygen last. Okay, so on the reactant side, we've got 1 hydrogen. And on the product side, that's going to distribute in, and we have 3. Oops, I need to write hydrogen right there. Okay, now let's do oxygen. So I'm going to clear this so that it makes a little more sense what we're doing here. Kind of get rid of some things. Okay. So notice how oxygen is in every formula. So when this happens, we have to add them together. Okay. So right here we've got 3 times 3, so we have 9 oxygen there, plus 1 there. That equals 10. Okay. Then here we have 3 oxygen, and we have 3 here. So 3 plus 3 equals 6. Okay. Now that we've got all these, let's go ahead and start balancing. And I'm going to erase that again so it looks clean. Okay, so first of all, our LAs are 1 to 1, so we're fine with that one. Our nitrogens, we've got 3 on the reactant side, only 1 on this side. So let's go ahead over here and put a 3 in the front. Okay, because remember, all we can do is add coefficients, and coefficients always go on the left-hand side. So now we have 3 nitrogens on that side. Okay, but when we do this, it makes it so that we unbalance other things. So let's just keep going and see what happens. Okay, now let's go to sodium. Right now we have 1 on the reactant side, but now this side is changed to 3. Okay, because of that coefficient. So now we need to make the reactant side have 3. So what are we going to do? We're going to add a 3 right there. Okay, so now that makes that one balanced. Okay, now let's double check our hydrogens. Okay, our hydrogens here. Now we have 3 because remember that distributes behind. So now on the reactant side we have 3. On the product side we have 3 still. So that's fantastic. Okay, now it's time to check the oxygen. Okay, I'm just going to get rid of that. Oopsie. Keep that 3 there. Okay, now let's check our oxygen. So on our oxygen, we've got 9 here. 3 times 3 is 9. Plus now we have 3 here. So let's change our oxygen on the reactant side to 12. Okay, on the product side, we distribute in, that's 3 plus, and then right here, this has a subscript of 3 times 3. So we have 9 there, which equals 12. So a lot of times when you do these, when you balance one, it unbalances another, but a lot of times it helps us balance the other atoms as well. So now we have a balanced chemical equation, and here's what it looks like all nice and clean. We've got a 3 in front of the sodium hydroxide and a 3 in front of the sodium nitrate, and everything is balanced. Okay, let's do another one. Okay, this is number 4 on page 4. Okay, this is zinc plus oxygen makes zinc oxide. So let's go ahead and write down a little chart again. It's nice when we only have 2 elements because it's not so crazy. We'll make this one look Christmassy. Okay, on this side, reactant side, we have 1 zinc. Product side, we have 1 zinc. Oxygen, we've got 2 on the reactant side, and now we have 1 on the product side. So we need to balance this oxygen. So right here, we've got 2. We have 1 on the product side, so we're going to go ahead and just put a 2 in the front. Okay. Now it makes our oxygen have 2 because that distributes. But it's changing the zinc now to 2 on the product side. So now we have to make 2 on the reactant side, so we're just going to put a coefficient of 2 right there. And now this one is balanced. And there it is, a 2 on the zinc and a 2 on the zinc oxide. Okay, let's do number 5. So number 5, we've got 3 different elements here. Okay, we have Sb, which is antimony, hydrogen and oxygen. Okay, so Sb we have 1, here we have 2, so we need to make this one have 2, so let's go ahead and put a 2 right there. Okay, then we'll do hydrogen next. We've got 2 on the reactant side, 2 on the product side, so that's nice. Oh, let's change that to be a 2, sorry. Okay, then our oxygen, we've got 1 here, and we've got 3 here. So we've got 1 and 3. Okay, this doesn't work. So what we need to do is put a 3 in the front of water, so that now changes. But when we do that, it now changes our hydrogen. So with our hydrogen, now we have 6, because that's going to distribute. And over here, we only have 2. So 2 times what makes 6? We're going to put a 3 right there, and that makes a 6. Okay, let's double check. 2Sb, 2Sb. 3 times 2 is 6 hydrogen. 3 times 2 is 6 hydrogen. 3 oxygens and 3 oxygens. So now we have a balanced chemical equation. And there it is. Okay, I hope that helped. I'm going to put up some more example problems, but these are, again, problems 1 through 5 on page 4 in your packet. Also, notice how this is just what we did on Friday with the Lego lab. Instead of using Legos, though, we're using a chart. It's not taking us as long because we don't have to build our formulas. But if it helps you to build formulas or to draw squares, use beads, pieces of paper, whatever it is that helps you, do it. Because the more you do it, the more it will help. Okay, thanks.